Hello everyone and welcome back. This is Saurabh Yadav, and in this video we are going to have a discussion around the OSPF redistribution. So basically we're going to learn that how we can really redistribute the other routing protocols into OSPF, which all options are available during redistribution, and how we can really utilize them. So this is what we are going to have a discussion in this video. Also, we will be performing some smaller labs for the redistribution, right? So first of all, you may ask, or somebody might ask the question, that why do we require the redistribution? So obviously, if you have two separate routing domains, right, then you may have to perform redistribution in between them to allow the communication. So like in this diagram also, we did this redistribution even in a previous video as well, but since this video is dedicated only for redistribution, that is why we are going to perform that redistribution again, right? So we are having one service provider. In fact, not one, we have two different service providers, ISP1 and ISP2 here. You can see that. And EBGP is running between router 1 and ISP1, and then router 2 and ISP2. So router 1 and router 2, those are working as the customer edge routers. So BGP is running there, and let me specify the customer BGP AS over here. So let me put the text here. So BGP AS 65500, and this is how it's been configured. So on customer edge routers, I'm using BGP AS 65500 on router 1 and router 2 both. And if we want to take a look at the configuration, then let me just display you that. So BGP is pre-configured, show run pipe section router BGP. So you can see that BGP is configured, and then also we can see show IP BGP summary, right? So we have BGP peering up and running, and we have received 6 prefixes from this neighbor. We can see the BGP table, right? So we have BGP running in between PEC, and in similar way we have BGP running between router 2 and of course the ISP2. If I get the access of router 2 this time, so I can prove that okay, BGP is also running over router 2. And internally, that BGP process 1 and area 0 is configured over router 1, 2, 3, 4. Like this is the complete infrastructure where we are using the OSPF. So obviously, if you really want that the users participating in OSPF routing domain to communicate with the service provider prefixes where we are running BGP, then obviously we will have to allow the redistribution between BGP and OSPF, because without doing redistribution, prefixes cannot really move from BGP routing domain to the OSPF and vice versa. So you will have to perform mutual redistribution over router 1 as well as over router 2, because we have two CE routers. So on both of the CE routers, we will have to perform redistribution, right? So I'm not going to cover that how to perform redistribution into BGP. However, to have bidirectional connectivity, it will be required by me to perform this type of redistribution. Like I'll have to redistribute OSPF into BGP so that I can perform some ping pong, and we can verify, we can perform testing for the end-to-end connectivity, right? So over router 1, I'm just going to redistribute OSPF into BGP, and to do so, you just go to router BGP 65500, just say redistribute OSPF 1, and that's it, right? So now if I look at the BGP table, I have all of those prefixes, which means that routes have got redistributed into BGP from OSPF. Similarly, I'll have to perform over router 2 so that prefixes can be redistributed into BGP. So you go to router BGP 65500 and then say redistribute OSPF and then process ID, which was 1. And again, we should have all of the prefixes in BGP table, so which is absolutely fine. And then we will have to ensure that we are redistributing routes into OSPF from BGP, right? So now, while doing redistribution from one routing protocol into another routing protocol, you will also have to consider a few additional things. Like you will have to make sure that routing loop does not occur due to your redistribution. Like what can happen is that, for example, if you are redistributing anything, let's say over router 1, right? So you redistributed probably BGP into OSPF over router 1. And then it is possible that router 1 might give those prefixes back to router 2, and router 2 can redistribute them back into BGP. That's possible. So we will have to ensure that that's not going to happen, right? We just have to make sure that. So during redistribution, it's not like you just go ahead and perform the redistribution. You will have to make sure that, okay, due to redistribution, there is no routing loop. In fact, like as of now in BGP, basically what's going to happen is like there is a default rule that when you redistribute anything into OSPF, right, then you know very well that type 5 LSAs will be created, right? And all of the external prefixes will get advertised into OSPF as an external prefix. And then also you are redistributing OSPF back into BGP, right? You are also redistributing OSPF back into BGP, right? So you just have to ensure that you are not redistributing those prefixes back into BGP. However, in my case, even if router 1 is giving anything to router 2 via OSPF, and if the same prefixes are coming from eBGP neighbor and same coming from OSPF, obviously it's going to prefer the eBGP. However, if it was iBGP, just imagine what could happen. Then obviously it should have preferred the OSPF only. Then obviously there could be a problem then. And you should know that how to avoid that kind of situation. I'll let you know that how we can really avoid the routing loops and everything, right, during redistribution. So thing is this, that we are going to redistribute now from BGP into OSPF, because we have already performed the redistribution from OSPF into BGP. So let's perform redistribution from BGP into OSPF over router 1. So what first thing is, first you just go to router OSPF 1 and then say redistribute BGP, and then its AS number 65500. And then you can also add the subnets keyword. Subnet keywords allows your router to redistribute the classless prefixes as well, because by default, only classful prefixes will get redistributed into the OSPF. However, in this latest iOS version, it's not really needed. It's not needed to have the subnets keyword in place, because even if you do not add the subnets keyword, it will be added automatically, and all types of prefixes, whether those are classless or classful prefixes, will get redistributed into OSPF, right? So when you redistribute BGP into OSPF, now remember, your prefixes must have got redistributed into OSPF now, and to verify that, you can always take a look at the database table. In database table, you must find type 5 LSAs, and yes, we can find them. So you can see that router 1 is originating type 5 LSAs. You know why? Because router 1 is working as an ASBR. In fact, if you say show IP OSPF in the output of this command, you can easily see it that this router is working as an ASBR, and we are redistributing external routes from BGP AS 65500 into OSPF, including subnets. So that's what you can see. So type 5 LSAs are being originated by router 1 because it is working as an ASBR, and each, you can see that by default, if you open up the type 5 LSA, show IP OSPF database external, and then 150.1.0, look at this type 5 LSA. So advertising router is the router ID of the ASBR, the originating router, and then link state ID is defining the network ID, and also it is containing the subnet mask value, which is network mask, and then also we are having metric type 2, which is type 2, right? So that way you can define your, you can see that the default metric type is 2 when you redistribute anything into OSPF. So that's the metric type 2. And the meaning of metric type 2 is that the metric for this prefix 150.1.1.0 via this advertising router will be considered as larger, right? However, its default metric is 1, which is okay. This is also known as the seed metric. I'll let you know that how you can really modify that. But thing is that by default, it will pick its seed metric, its default metric as 1. By default, forwarding address is going to be 000 in such conditions. And yeah, it should be 000. And the meaning of forwarding address 00 is that you can ignore the forwarding address. If it was any other value, then you cannot really ignore that. And then routers, like if any router receives the type 5 LSA coming with the forwarding address, then first it will check if it has reachability to the forwarding address. If not, then that route will not be installed in its routing table. Then the routers will have dependency upon the forwarding address reachability. Then tag, because in BGP we had the AS path attribute as a that it was containing AS number 100 in its AS path list, and therefore the tag was 100 over here. You can modify all these things, right? So what I'm going to do, I'm just going to modify this tag value for now. So I'll just go back to router OSPF1. I'll simply execute the same command, but then I will put the tag value, let's say 1. So this time the OSPF database table should have the tag value as 1. So I have modified that. So you can always modify that. Then I'm going to perform the redistribution over router 2, right? Saying that router OSPF1 redistribute BGP 5565500, and it's not typing up. Probably there is a latency. Just let it come up. Hold on. Just give it a moment. Sometimes it gets stuck. I'm connected to the lab through the VPN. Yeah, so it's back now. 65500, and then tag value. Let's say I kept as 2, right? And now look at the database table. In database table, you can see that, because see, I'm a CE, right? Router 1 and router 2 is working as a customer edge router, and both of the customer edge routers are receiving the same prefixes from their provider router, from the PE router, right? They are receiving the same prefixes. Now I have got them redistributed into OSPF, and therefore the type 5 LSA is being originated by router 1 and router 2 both. You can see that for same prefix, right? For the same prefix, you can open up, because you can look at the link ID, because in type 5 LSAs, the link ID will indicate your IP prefix. So you can see that 150.1.1.0 is been redistributed into OSPF by router 1 as well as by router 2. The only difference is tag value, right? So router 1 had tag value 1 because I defined that, and thereafter router 2 had tag value as 2 because I defined that manually. So now the redistribution has been done on router 1 and router 2 both, right? And therefore router 3 must receive the type 5 LSA coming from router 1 and router 2 both. So let's move over router 3 and let's see that how is it going to take the decision for the best path selection, right? Just give it a moment. Please. Yes. Okay. There you go. So this is router 3. Now look at the database table once again. Show IP OSPF database. And in the end, you have type 5 LSAs, and you can see that this prefix is coming from, like this type 5 LSA is being originated by router 1 as well as router 2. But which path is the best path, right? How is it electing its best path, right? So let me open up this type 5 LSA in details first. Show IP OSPF database external, and then 150.1.0. Hit enter. You can see that this type 5, like there are 2 LSAs for this prefix, right? One is originated by router 1. The other one is originated by router 2. Both of them have set their metric type as 2, right? So, both of the ASBRs are advertising these type 5 LSAs with the metric type 2. So obviously, both of them are saying that, hey, the cost through us, right? The metric through us is larger than any other link state path. So basically, the metric type is common. So based on metric type, router cannot take the decision this time, right? Even if you look at the routing table, right? Show IP route, look at the routing table. So it has installed this prefix, right? But from where it has installed this prefix in its routing table, you would, you would come to know about that by executing this command. Show IP, let's say show IP route 150.1.1.0. Look at the routing table in details, and then it will display you, okay, it's going through 111. So that's the best path. So via 1.1.1, it has defined its best path. Now, why is it? Because the metric type is common from both of the customer edge routers, like from router 1 as well as router 2. The metric type is common. So remember that in case if you have multiple ASBRs in your area, and if you're receiving the same prefix coming from multiple ASBRs, then first preference will be given to the metric type, if metric type is common, like in our case, it was metric type 1, right? Then it is going to compare the cost to reach an ASPR. So look at the cost to reach an ASPR. And to know about that, the command would be show IP OSPF border router. So now you can see R1 is the cost to reach R1, which is working as an ASPR, is 10. And then the cost to reach router 2, right, which is also working as an ABR and ASBR both. But for now, I'm just considering ASBR. So the cost is 20 then. The cost is 20. So among router 1 and router 2, we are having lower cost via router 1, and therefore the best path to reach this 150.1.1.0 has become via router 1. But then if you say like over router 3, let me just increase a little cost here for router 1, let's say, right? So what I'll be doing, I'll just go to interface Ethernet 0x1 and IP OSPF cost, let's say 100, right? So I've increased the cost to reach the router 1, right? So now you would see that the cost to reach both of the ASPRs, right? So to reach router 1, the cost is 30, but to reach router 2 is 20. Like via Ethernet 0x1, now router 3 is not reaching out to this router 1 because the cost is higher than via router 4 and then router 2 and then router 1, because via router 4, 2 and then 1, the total cost is 30, whereas on this Ethernet 0x1, I had cost configured as 100. And when you receive any LSA on Ethernet 0x1, you are going to consider the cost of the receiving interface, right? And then that's how you will calculate the total cost. So for now, the best path is, best path should be via router. Okay, let me move over router 3 first. Oh, router 3, right? So for router 3 now, the best path should be via router 2 to reach out to the external prefixes, right? So just look at this route in more details. So now, yes, the best path is via router 2. So you can see it now. The traffic will go from router 3 to router 4. And from router 4 to router 2, and then it will go, it will go towards the internet, like trace route 150.1.1 and then numeric, right? But then if you go back and you remove the cost value that you configured over Ethernet 0x1, say no IP OSPF cost 100. So that's how, I have covered one more concept here. Like you came to know that how to modify the cost of the interface manually, right? Like by default, OSPF will be calculating the cost values for each interface based on its cost calculation formula. But in case if needed, you can also modify the cost of the interface individually by going to interface mode and by executing this command. Now, as soon as you do that, once again, if you say like show IP route, then again, the best path is via router 1. And if you do the trace once again, then you should go via router 1. So you are going to router 1 and then via ISP1, you are reaching out to your destination, right? So it has been proved that the cost to reach ASPR is taking place in case if you have multiple ASPRs and both of the ASPRs are advertising their prefix as the type if they are using type 2. So remember, when you do redistribution into OSPF, the default metric type will always be metric type 2. However, there is one more type that you could configure manually, that is type 1. So basically there are two types, E1, which is also known as type 1, and E2, which is also known as type 2. So by default, there will be a type 2, but then you can modify it. And remember that type 1 is always preferred over type 2. I'm repeating my statement. Type 1 is always preferred over type 2, right? So when you look at the route here, right? So metric type, the metric type is external type 2, right? But then it could be 1 as well, like you have to configure it manually. But remember that type 1 is always preferred over type 2. So let's say if somebody says like there could be a requirement that router 1 is primary, but in case if it goes down, then secondary should be there, secondary should take place. So as long as router 1 is up and running, then traffic should always go via router 1. And if router 1 goes down, then obviously it should take place via router 2, or maybe, in reverse manner. Router 2 is primary. So if router 2 is primary, then you go to router 2. And during redistribution, you just have to say that router of SPF1, you redistribute it with the tag 2, but then also you could define the metric type and as 1. As soon as you do so, right, let's say you define the metric type 2 now. Let's go back to router 3. I haven't changed anything, right? So first, let me display you the LSA. show IP OSPF database external for this prefix 150.1.0. Look at this. So again, I'm receiving this LSA coming from router 1, but from router 1, the metric type is still 2. But via router 2, like router 2 is also originating this LSA, right? And this time the sequence number has been incremented because I modified it, right? So ASPR had to regenerate this type 5 LSA. So it has been regenerated by router 2. And this time you can see that metric type is 1, and therefore the best path for router 3 must be via router 2 only. So you can see that it is via router 2. However, it is doing ECMP. You know why? Because to reach router 2 from router 3, it's doing ECMP. It can reach out to router 4 via router 1 as well as via router 4. So there is a equal cost load balancing. But there is a problem now. The problem is that since your router 3 is doing ECMP to reach out to router 2, so some traffic will go that way, will try to reach destination from that way, and some traffic will go from this way because router 3 is doing ECMP, right? So if it is going via router 4, there will not be any issues. Then it will go to router 2 and then destination. However, there is an issue if router 3 is trying to send the data towards router 2 via router 1. Because router 1 will perform the routing lookup independently. And since router 1 is already receiving those same prefixes from its eBGP neighbor, so that therefore the traffic will be given, the data will be given to ISP1 directly. So if traffic reaches out to router 1, then there is a problem, because for router 1 the best path is still via eBGP. In fact, you can go to router 1 and then you can see that. So if I go to router 1, and if you look at the routing table, it should still prefer those external prefixes for 150.1.1.0, right? So if I go back to router 3 and if I do the trace once again, just hold on. If I do the trace route once again, so it's going through ISP1. Also, it is going through the ISP2. But that depends that from where the traffic is going out. Is going. If it is reaching out to router 1, then obviously router 1 will directly give it to the ISP1. It will not give it to ISP2, right? Although there is a way to avoid this situation as well. I can avoid that situation, right? In BGP, there is a solution. Like by default for eBGP, the AD value is 20. You have a feature in BGP that you could utilize here on router 1, and you could change its AD value from 20 to 200. Then for OSPF, the AD value will become 11. Like for OSPF, the default AD value is 110, but for eBGP, it will be 200. Therefore, even for router 1, the best path will be via router 2 to reach your external prefixes, to reach your internet, right? Like I can certainly enable that feature inside BGP network 150.1.0 and then 255.255.0 and then say backdoor. The network 150.1.2.0 backdoor. Network 150.1.3.0 backdoor. Network 150.1.4.0 backdoor. Network 150.1.5.0 backdoor. Now, as soon as you do that, now look at the BGP table, right? So in BGP table, it should not be a best path now anymore. It is. Then it, the backdoor keyword is not working. So probably backdoor keyword will work only for the classful prefixes. Then I believe so. I can wait for some more time. No, it's not taking place. So yeah, it's going to work then for classful prefixes only. The backdoor keyword. It's not working in that way, right? Because as soon as you execute that backdoor keyword, then the AD value via eBGP will become as 200, and then it should start preferring the OSPF only, right? But somehow that is not working here, so it will work only for the classful prefixes then. Network 150.1.0 mask. Let me just try to put in that way, if that is possible. Let me test for first two prefixes only. Show IP BGP. Yeah, it's working now. It's working. Yep, it's working. So for 1.0 and 2.0, there is a RIP failure in BGP, which means it's not installing them in routing table via BGP this time. So if you look at the routing table now, so first two prefixes are coming via OSPF only. You see that? So basically we needed to add the subnet mask value. So we can do it for all remaining three prefixes as well. 65500, let's say network 150.1.3.0 mask, and then backdoor. Then 4.0, and then 5.0. Show IP BGP. Yes, it's there now. And it's working perfectly fine. So if I go to router 3 and do the trace route once again, it's all going through the router 2. You know, router 2 and then ISP. In case if over router 2 BGP peering goes down, let's say, so for example, over router 2 somehow the interface went down, right? Ethernet 0x3 shut down. No worries. From router 3, traffic will go directly via router 1 now. Look, it's going via router 1. So the best path is now via router 1. And as soon as you go back over router 2, so don't ask me that backdoor feature for now because we are covering the OSPF here, right? But I had to do that because I just wanted that kind of capability inside the OSPF because in OSPF the AD value is 110, and in case of eBGP it was like I could do that by the help of modifying the AD value itself, but like since we had that feature available in BGP itself, so it was not really needed to change the AD value. Although in backend it is also changing the AD value because for eBGP the default AD value is 20, but then if you put that backdoor keyword with the network command, then obviously the AD value will become 200 then via BGP, right? So that's how you could do that. Or maybe if you don't want to use that backdoor keyword over router 1, so just go to router BGP 65500, just remove all these commands, right? Okay. And once again, the best path will become via eBGP only, right? Yep, that's that. But then what you could do, you could just go to router OSPF 1 and then distance. Maybe some changes, or maybe it's not supporting that command. I'll have to take a look. I'll have to say default metric. Now, sorry, just a moment. Let me see that. How can I really? Here is the distance keyword. I don't know why it was not displaying before. OSPF, and for external, I'm going to set it up like 19. It's done. Now look at the routing table. Once again, OSPF external prefixes are preferred over the eBGP. So yeah, I mean, it's up to you that how do you want to achieve your task, right? Your target. But yeah, I mean, since R3 was doing the ECMP, we had issues, right? Even though the best path was via router 2, but still some traffic was going to router 1. And for router 1, the best path was via eBGP. So to avoid that situation over router 1, I just configured the AD value of OSPF external prefixes as 19, which is lower than EBGP. Therefore, even for router 1, the best path for external prefixes will be via router 2. So in case router 2 goes down, then the best path will become via router 1 itself. So that's how you could utilize the E1 and E2. So remember that E1 is always preferred over E2. There is no chance that E2 will be preferred over E1. No, not at all, right? Even though if you modify the cost or whatever you want to do whatever you want to do, but remember that E1 will be preferred over E2. Okay, so that's that. Thereafter, if you want to modify, like for example, via both of the routers, the type is E1, right? So let's go to router OSPF1 and then let's remove that distance command, and thereafter let's say redistribute. Is gone. So let me redistribute it again, right? Redistribute BGP 65500 tag 1 and then just say metric type 1. So again, it's metric type 1, right? So then prefixes will be coming to router 3, right, from router 1 as well as from router 2. So which one will be best path then for router 3? That you need to take a look, right? So so now for router 3, the best path selection will be done based on the cost. And one more thing that I would like to display you the difference. If you open up the type 5 LSA this time, so router 1 is originating, it's type 1. Router 2 is also originating and it is also type 1. And the meaning of type 1 is that comparable directly linked state metric, which means that it can compare the metric for the purpose of best path selection. And how is it going to compare? So first it is going to compare your seed metric. Even if both of them were E2, so first it will compare the seed metric, which is by default 1, which was equal, and then it was comparing the cost to reach an ASBR. And in same goes in case of type 1, right? So if it is type 1, then it is going to compare the total cost to reach ASBR, and of course plus the seed metric, and then it will calculate the total metric, right? So for router 3, which path is the best path for now? You can see that seed metric is common. Type 1 is from both of the ASBRs, but still, which path is the best path? Show IP route. Look at this, that it is via router 1. Why? Why is it via router 1? Because if you look at the total cost, that's 11, right? So if you look at the show IP OSPF border router, the cost to reach router 1, which is an ASBR, is 10, and via router 2, it's 20. So if you include the total cost, via router 1 in total cost, it will be 11 because type 5 LSA is containing cost as 1. So the total cost will be like cost to reach ASBR plus cost contained by the type 5 LSA, right? So type 5 LSA was containing its cost as 1, and the cost to reach ASBR from here is 10. And via router 2, it will be 21 in total. Therefore, the best path has been elected by router 3 via router 1 at the moment, right? Then you can also change the seed mapping if you really want that, right? So over router 1, router OSPF 1, and then you just put that redistribute command again, and then you can change the metric. Let's say I said 2, that it's 2 now, right? So if you look at the type 5 LSA once again, look at this. Now seed metric is 2 via router 1. It is still 1 via router 2. Now look at the routing table. It is still via router 1. However, the seed metric is higher because see, it is not comparing the seed metric. In case of if it was E2 via both of the ASBRs, then it should have compared the seed metric. If the metric type was common like as E2. But this time it is not E2, it is E1, and therefore it is comparable, and that is why it will be calculating the overall cost, the cost of the cost to reach ASBR from here plus the cost contained by the type 5 LSA, which is still lower via router 1. But then if you go by router 1, if you increase a little more, let's say in place of 20 you said 100, that's the seed metric, and this time if you open up the LSA, so from router 1 the seed metric is 100. From router 2, it is still 1. And therefore, the total cost will be lower via router 2. And therefore, if you say show IP OS, look at here, show IP OSPF border router, right? So to reach router 2, it's 20 via router 1 as well as via router 4, right? So we can reach out to router 2 via router 1, like in the diagram. From router 3, you can reach out to router 2 via router 1 or maybe via router 4. And via both paths, it has same cost. Therefore, router 3 is displaying these, both of the entries here for router 2. And then look at the routing table, show IP route. Look at this. That for reaching out for reaching out this destination prefix, the best path is via router 2. And this time the decision is taken based on the total metric, which is lower via router 2. However, it is doing ECMP, so some of the data will be going via router 1. And for router 1, the best path is still via directly eBGP neighbor. So traffic will be given to the eBGP neighbor rather giving it to router 2. So again, you will have to apply the same kind of solution if you really want that your traffic should go via router 2 only to the internet. Because in case if traffic reach out to router 1, then for router 1, the best path is still via eBGP neighbor. So either use backdoor feature inside BGP or modify the AD value inside OSPF itself. It's up to you that how do you want to do that, because we have already done that, right? So that's how the metric type, in case of metric type 1, it is comparing the overall cost for calculating the best path for the external prefixes, right? Now let's go back to the redistribution once again. Over router 1, now you could also modify like tag value. We have already modified that, right? Subnets we know. Now the only thing which is left is an SSA only and then route map. An SSA only, I'm not going to consider that for now because that's not part of the redistribution. That is something that I'll be discussing around the type 7 LSs, like when I'll be covering the type area types, and then only I'll be explaining the use case of the NSSA only keyword along with the redistribution command. But for now, route map is pretty important, right? See, we are defining here tag, seed metric, metric type, whatever. And also, I just want to make sure that I redistribute only some specific prefixes, because if you do not use any route map, and if you're redistributing BGP into OSPF, remember that all of the prefixes that you were learning via eBGP or via BGP will get redistributed into OSPF automatically. So you are not putting any kind of limitations. You are not matching any conditions. There are no conditions at all. So that's the problem, right? So to fix that issue, now you could utilize the route map. So if you say show IP route and then you have like 150s prefixes, you still have 150s prefixes, right? I don't want to redistribute all of them. Let's say I just wanted to redistribute only first 3 prefixes. Let's say that I just wanted to redistribute only first 3 prefixes. So I can certainly do that, right? I just have to create the prefix list. Just create the prefix list, IP prefix list, right? Red to OSPF, right? Permit, and then just say 150.1.0.0/22 greater than equal to 24 less than equal to 24, and it will match all those 3 prefixes, right? And then create a route map. Even you can put the same route map name here, and then sequence number, permit 10, match IP address prefix list, and then your prefix list name. Right? Put it there. And now you can match. I mean, you can set whatever you want to set. You have matched all those prefixes which you wanted to redistribute from BGP into OSPF. Now you could do one thing. Set tag. Let's say I wanted to set tag 11 this time. Metric. Set metric type 1. Type 1, right? Then set seed metric. Like by default it was 1, but then certainly you can set 10. I mean, whatever you want, right? Set tag, set metric type, right? Set tag. You can set all these things inside the route map. But for now, I know you know that I just have to, I just needed to set the metric, seed metric, the metric type, and this is what I have done, right? And then create another statement for the same route map with sequence number 20. with the deny keyword. Deny 20. However, by default, it will deny, but yeah, I mean, it's always best practice to keep the deny keyword explicitly, right? And do not match anything, because if you do not match anything, by default, it is going to match any, right? So anything else will be denied. Now look at the statement of the route map. Show run pipe section route map. So you said, hey, I want to permit which are matching with this prefix list, but also I want to set metric, seed metric 10, metric type 1, and set tag 11. And then you go back to router OSPF now. 1, say redistribute BGP 65500, and then say route map, and then route map name. So you don't have to say that set tag or this and that. You don't have to put all those keywords. So we did it by the help of route map. Look at this. So you can remove all that kind of stuff now. Just remove that. Just hold on. Now put that command again with route map like this. Show run pipe section router OSPF. So subnets keyword was added automatically, right? So this time only first 3 prefixes should get redistributed. Therefore, in database table, you must see only first 3 prefixes part of your type 5 LSAs in database table advertised by router 1. Like in case of router 2 is still doing the redistribution for all of the prefixes, right? So that's a separate case. So you can look at 1, 2, 3. So 1, 2, 3 is getting redistributed by router 1, right? Not anything else. 4, 5 is not being redistributed by router 1 into OSPF. You can see that 150.1.4.0 and 5.0. Those are redistributed by router 2 only, because on router 2, I have not applied any kind of route map or something like that, right? So that way you could leverage, you could utilize the route map. So I hope that you understood that how you can really utilize the route map during redistribution. Now, one more thing that I would like to display here. Let me go back to router OSPF1 and let me also remove this command. So the redistribution will be stopped now, right? Similarly, I'm going to stop this redistribution over router 2. Let me just remove this prefix now. Fine, it's done then. And no redistribution is happening in database. Like there are no type 5 LSAs now. Oh, is it still there? Sure, run. Hold on. Pipe section. Oh, okay. Look at the database table now. There are no type 5 LSAs anymore. You see, timer is going to get expired now. The time has been. What happens is that if something goes down, like if you remove anything, then OSP will set its age as 3600 second. And the meaning of 3600 second is like age out, so that OSPF can remove them from its database table, right? And those have been removed now. So no redistribution. Let's get back to router 1. You know that if I'm redistributing BGP into OSPF, right, by default, the cost was 1. But then if you go to router OSPF1 and if you say default, area 0, default cost. Look at this. Let's say I said 10, right? Area 0 default cost is 10. And then I'm going to redistribute, let's say. Will it really make any difference here? Let me see that. Redistribute BGP 65500. Show IP OSPF database. Yes, it's there. And then show IP OSPF database external. The default cost is still 1. Yeah, it's not going to. Okay, there is a command. Actually, I wanted to cover that, but it's not part of the redistribution. I'll be covering that default cost, area 0 default cost 10, and the use case of this command later on, but not now, because it's not going to affect anything during the redistribution. Yeah, I mean, you can certainly change the seed metric. You could change the metric type. You could set the tag value. So these all things you could perform with your redistribute syntax, or maybe by the help of the route map. Even it is always recommended to use the route map, right? And in fact, in OSPF, what you could do, like if you are doing redistribution, right? And if you really want to avoid the routing loops, so better that if you are redistributing anything on router 1, set the tag value and then filter the tag value back on router 2, like this. So because there could be a problem, right? Somebody might modify the AD value and then it may lead towards a routing loop. So better is that, for example, if you are doing redistribution here, redistribute BGP, right? And then tag value. Let's say I said 11, right? Show IP OSPF database. So with tag 11, these prefixes will go to router 2 now, right? Because LSAs, you cannot really stop them. So those are available over here, right? So in case if somebody changes the AD value for eBGP, obviously router 2 will install these prefixes in its routing table. But at any cost, I don't want router 2 to get these prefixes installed in its routing table, because if that happens, then obviously you may also redistribute OSPF into BGP. So these prefixes will also get redistributed into BGP, and that may lead towards a routing loop. So you don't want these prefixes to be part of your routing table at any cost. And to do so, you could simply filter routes based on the tag value, right? You could say route map, filter, deny, 10, match tag 11, and then all other prefixes are allowed. So you would say permit 20, and you are done. Everything else is permitted as per the route map. And then go and apply the distribute list route map, and that name was, so it's kind of like filtering the routes, right, in inbound direction. Globally, I have applied it, right? So these routes will never ever get installed in my routing table coming with the tag 11. So if I look at the database table, in database table, the prefixes will still remain there. However, those prefixes will never ever get installed in its local routing table, even though if somebody changed the AD value, like somebody said, hey, the distance for OSPF external, and let's say it's 19. Still, prefixes are not installed in routing table because we are filtering them, right? Those are not installed yet. Look, still it's BGP, right? But then if you remove that distribute list from here, which you used for the purpose of filtering, now look at the routing table. Wow, it's the router has installed the routes, the external prefixes, the internet prefixes via OSPF this time. So it may cause a problem because probably you are redistributing OSPF back into BGP, right? So these prefixes might get advertised back into BGP. They were coming from BGP at one CE, and other CE is getting advertised them back into BGP. So that could lead a routing loop. You should not do that, right? So if you are redistributing anything on CE1, which is router 1 in this case, you set some tag value and get them filter out on router 2. And similarly, if you are doing redistribution over router 2, set some tag value and then filter it over router 1. by applying some distribute list. So that's how you should perform the redistribution into OSPF, and these all different features were available during the redistribution into OSPF. There are one or two more features, but that we will cover at the time of there is one feature left actually that we can cover later on when we cover the area types into OSPF. So this is what I wanted to cover in this video. So thanks for watching.